Okay, we just discussed who's coming to the rescue. Common denominators. They come flying in, right? Being like, let me help you with this, guys. Okay, so with your highlighter here, you're going to highlight the denominators of the two fractions that we're comparing. So I'm going to go ahead and highlight the 4, because it's the denominator of 3/4. And I'm going to highlight the 6, because it's the denominator of my second fraction. And we are going to try and get common denominators, because right now, these are not common. They are not the same. We want to make these parts exactly the same so we can be super duper duper precise in our comparison. So in order to do this, we're going to look at this 4 and find multiples of 4. We're going to look at that 6. We're going to find multiples of 6. And we're going to stop when we get to something that's common. Okay? So I'm going to start with the first multiple of 4, and that's 4. Okay? Now if I go to the second multiple of 4, and maybe you know it before I do and you could fill it in, is 8. And now I'm going to the third, and that is 12. And I could just keep going, but I stopped for a certain reason, and you might see why. So now I'm going to go to the multiples of 6 and start listing those. Does it start with 4? No, it starts with the number we're working on, 6. Okay, 6 times 1 is 6. Now I double that. And I'm at 6 times 2, which is 12. Cha-ching, 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 cha-ching. There it is. Oh my gosh, these are common. This is going to be our common denominator. Okay? So now I'm going to go over to my picture and I'm going to show what this means. Okay? So in the picture, we have the fraction 3/4. Let's take our pencil and shade in 3 out of those 4 parts. So I shaded in 1 part, 2 part, 3 parts out of 4. Then I go and I start shading the 5 parts out of 6. 1, 2, 3, 4, 5. Okay, now I'm going to go, and you can still see it's a close call here. And now we need to make those parts common. So I'm going to go ahead and write up here that now our 4 parts is going to become 12. Okay, and our 6 parts is now going to become what? 12. So that we have, back to the highlighter, common, with sunbeams around it because it's super exciting, common denominators. Okay, so now let's make that happen in the picture. All right, so I'm going to pick up my colored pencil and I am going to split each one of these parts up into more parts because I'm trying now to get 12 parts. Well, how the heck do we do that? Right now I have 4 parts. If I double each part and I make 2 parts in each one, then will I be at 12? No, I'll actually be at this number, 8. But if I triple each part, I'll have 3 in here, 3 in here, 3 in here, 3 in here, and guess what? 4 groups of 3, or 4 times 3 is 12. This was the third multiple. So I'm going to split each part into 3 parts. Okay? Now this is weird because you're only going to use 2 lines to make 3 parts. So watch first. And now I've taken that 1 part and split it up into 3 equal parts. Do your best. And then I go to this next part, and I'm going to split that into 3 chunks, and the next into 3 chunks with my 2 lines, and the next into 3. Okay? There we have it. Guess what? Now we don't have 4 parts. Now we have 12 within the same rectangle. And we're still looking at this same shaded portion. So now, instead of just 3 parts shaded, how many parts do we have shaded now? It's still the same area. It still takes up the same amount of space. But now we have, I'll write it with my pencil, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 out of the 12 parts shaded. We have formed an equivalent fraction to 3/4, right? This is equivalent to this one. It represents the same amount of area. We just chopped it up into more parts so that we could compare these two fractions in a more precise way. So numerically, what the heck happened here? The 3 was morphed into a 9 and the 4 was morphed into a 12. Each one was actually multiplied by the same factor. Do you know what factor that was? It was not 1. It was not 2. It was 3. So we could go ahead and write that just in a cloud, in a bubble, to say, think about that. We're multiplying both the numerator and denominator by 3, by the factor of 3. And thinking about that, if I keep my fraction bar there, 3 over 3, 3 divided by 3 is really the same thing as 1. So we're really multiplying 3/4 by a fraction that's equivalent to 1. And any number times 1 is itself. So this represents the same amount as 3/4. It's just, we love this 12 because it's going to match up with the 12 over here. Okay, let's get to the colored pencil and chopping up these parts so that we have 12 of them. Right now we have 6 parts. So are we going to chop each one of these up into 3 parts? No, then we'd have too many. So how many are we going to make in each part? We need to have a total of 12. So if we double each one, make 2 in each one, will we have 12? Yes, we will. So let's go ahead and do it. Boom, bada boom, bada bing. And now, wow, we have 12 parts, same amount of parts as the fraction up here. All common denominators. Now, how many do we have shaded in? Because now we don't have 5 anymore. We have 2, 4, 6, 8, 10. Whew. Look at that. And now we have common denominators, and we can easily then say that 9/12, if we have 9/12, that is less than having 10/12 of something, because the 9 is smaller than the 10. So therefore, that's the symbol for therefore, 3/4 would be less than 5/6. Yes. And if you want to be super duper fancy about it, you could say, well, 3/4 is actually, let's see here. If I go up to the picture, line them up. Ooh, 3/4 is actually, how much is that worth? 1/12? 1/12 less than 5/6. And then other people around you would be like, whoa, you are fancy. Common denominators to the rescue. Be precise.